All right, strap yourselves in, everybody, because today's deep dive is taking us straight into the heart of testing in Rust.
Oh, yeah. This is where the rubber meets the road.
We've got some really interesting excerpts here from unitestrust.pdf, and, one thing that really jumps out is just how seriously Rust seems to take this whole testing thing.
Yeah.
It's not just about, like, finding bugs. It's something more, wouldn't you say?
It's about building that confidence, like baking it into the DNA of your code from the very beginning.
Yeah.
And that's where I think the Rust testing ecosystem really shines, because it gives you the tools to do it right. It's not just a box-checking exercise. It's about giving you that certainty. Like, you know your code does what it's supposed to do, no matter what.
Yeah, and I'm seeing that even in the way these excerpts are titled, like urging us to write more than unit tests.
Right.
And, okay, we all get the importance of unit tests, right? You got to
Yeah.
test those individual functions, make sure they're working as expected. But what's the big deal about going above and beyond that?
Well, think about it like this. You could build a house using only a hammer, right? You could probably make it work.
Yeah.
But wouldn't it be better to have like a full toolbox at your disposal?
Oh, absolutely.
That's what going beyond unit tests is all about.
I like that.
Yeah.
So what other tools are we talking about here? What's in this Rust testing toolbox?
Well, one of the most important tools you're going to reach for is the integration test.
Okay.
And unlike unit tests, which are all about those isolated functions, integration tests, they look at the bigger picture. They tell you how all the different parts of your code base are interacting with each other. Are they playing nicely together? That sort of thing.
Yeah, so it's like making sure that all the gears mesh smoothly in a clock, not just that each gear turns on its own.
Exactly. And what I find fascinating is how Rust actually structures these different types of tests within your project. So unit tests, those live right alongside your code, clearly marked with the hashtag test attributes, like having these little self-checks built right in. But integration tests, those live in their own separate tests directory. They're treated like external users, interacting with your code from the outside in.
Oh, that makes a lot of sense. So it's
Yeah.
like having that internal inspection at a test drive,
Mm,
before you actually hand the keys over to the user.
exactly.
But hold on, there's more, right? Because
Yeah.
we've got this doc tests thing. And I got to say, that really piqued my curiosity. It's like you're embedding live code examples directly into your documentation.
You hit the nail on the head. That's exactly it. And I think it's a testament to Rust's dedication to having clear, concise, correct documentation. You're not just telling users how your code works, you're showing them. And here's the kicker. Rust actually runs those examples as tests. So it guarantees that your documentation is always up to date, which is incredibly valuable when you're working with a language as powerful and as nuanced as Rust.
Absolutely.
Mm.
Okay, now let's talk about something that sounds a little more unpredictable. Fuzz testing.
Yeah.
It's like unleashing a horde of data gremlins on your code, right?
That's one way to put it.
Try to break it.
Yeah, you're essentially trying to find those hidden cracks in your code, those unexpected inputs that might cause things to go a little haywire.
So we're talking about those edge cases, those weird combinations of data that you'd never really think to test for manually.
Right.
And that seems especially important when you're dealing with things like security and data integrity and all that.
Oh, absolutely. Imagine your code is processing user input from a website.
Mm.
Well, a malicious user could try to input strange, unexpected data, maybe to crash your system, or even worse, gain unauthorized access. Fuzz testing helps you find and fix those vulnerabilities before they become real-world problems.
That's reassuring. So Rust has got your back when it comes to security.
Yeah.
But how does this fuzz testing thing actually work in practice? Because it sounds a little chaotic, honestly.
It is chaotic, but in a controlled and ultimately beneficial way. You're basically bombarding your code with random inputs and just seeing what happens, trying to make it break. And Rust provides tools to do this, like the cargo fuzz subcommand,
Okay.
which integrates with this really powerful functionality called libfuzzer.
So it's like you're stress testing your code,
Mhm.
pushing it to its limits just to see where it breaks.
Exactly.
And that seems like a really valuable approach, especially early on in the development process.
It is, because finding these vulnerabilities early is much, much easier than trying to patch them up later on when your code's already out there in the wild.
Absolutely. So we've talked about unit tests and integration tests, and even those intriguing doc tests and the almost scary power of fuzz testing.
Yeah.
It sounds like Rust developers have like a whole arsenal at their disposal when it comes to making sure their code is top notch.
Yeah.
But I have to ask, with all this emphasis on testing, doesn't it slow down the development process.
Whoa.
I mean, is it really worth all the extra effort?
That's the age-old debate, isn't it?
Right.
Time spent writing tests versus time spent fixing bugs later on.
Yeah.
And sometimes, yeah, it does feel like you're adding extra hours to your day, meticulously writing tests for every possible scenario. But here's the thing.
Okay.
Those seemingly extra hours,
Yeah.
they often save you from pulling all-nighters down the line, right?
Oh, tell me about it.
Trying to track down some nasty bug in a complex code base.
Yeah, I've definitely had my fair share of those late night debug sessions.
Right.
And they're not fun.
No, they're not.
But it's not just about saving time, is it?
Yeah.
There's a bigger picture here, right?
Absolutely. It's about fostering a different mindset, I think, a culture of confidence in your code. When you have this really robust suite of tests backing you up, you're not afraid to make changes, to refactor, to experiment. You know that if anything breaks, your tests are going to be there to catch it.
So it's about agility as much as it is about stability.
Exactly.
Interesting. You can move faster and with more confidence because you've got that safety net in place.
Precisely. And let's not forget the peace of mind that comes with a well-tested code base.
Yeah, that's true.
Imagine shipping software knowing that you've done everything in your power to ensure its reliability. That's a pretty good feeling.
It really is. And I can see how this approach would lead to, more robust and reliable software overall.
Yeah.
I'm curious, though, these excerpts that you shared, do they go into any specific examples of how these tests might actually look in practice?
They do.
Okay.
Yeah.
Because, I'm particularly interested in, like, how you would test for expected failures, like making sure a function panics under the right conditions, that kind of thing.
They do. And Rust makes it surprisingly easy to test for those happy path failures. Remember that hashtag test attribute we were talking about earlier? Well, you can actually use that in conjunction with the hashtag should panic attribute to specifically test that a function panics when it's supposed to.
Oh, that's pretty clever. So you're not just testing for success, you're testing for the right kind of failure.
Exactly.
Right.
It's about making sure your code behaves predictably, even when things go wrong.
Right.
And speaking of predictable behavior, the excerpts also delve into the use of integration tests for verifying the public API of your crate.
Okay, now for those of us who might not be fluent in Rust jargon, could you remind us what a crate is exactly?
Of course. In Rust, a crate is essentially a package of code.
Okay.
Similar to like a library or a module in other programming languages.
Gotcha.
So when we talk about testing the public API of your crate, we're really talking about making sure that other developers can easily and reliably use your code in their projects.
That makes sense. So you want to ensure that your crate integrates seamlessly with other parts of a larger project.
Right.
So these integration tests aren't just about individual functions, they're about the crate as a whole.
Exactly. They're like a final check to make sure everything's working together harmoniously. And to keep those integrations running smoothly, the excerpt emphasizes the importance of running these tests continuously.
Continuously, like all the time.
Well, not literally all the time.
Okay.
But the idea is to integrate them into your continuous integration and deployment pipeline, or CI/CD for short.
Okay.
This basically means that every time you make a change to your code, these tests are automatically run, catching any potential issues early on.
Ah, so it's like having this automated quality control system in place.
Exactly.
Okay, that's reassuring.
Absolutely. And this emphasis on catching issues early extends to performance testing as well. The excerpt actually mentions benchmarks and how easy it can be to misinterpret their results, especially with a language like Rust, where the compiler is constantly optimizing your code behind the scenes.
So even when we're talking about speed and efficiency, we can't just blindly trust the numbers. We have to be a little bit more discerning.
You do. You have to be critical.
Okay.
You need to understand the context, and you need to make sure that your benchmarks are actually measuring what you think they're measuring.
Right.
It's another example of Rust's kind of trust but verify philosophy.
Speaking of which, we haven't even touched on that handy things to remember checklist from the excerpt.
Right.
It seems like a great way to bring together all these different testing concepts and maybe provide some actionable advice for our listeners.
Right.
So before we wrap things up here with with our deep dive into this whole world of Rust testing, I think it'd be good to revisit that things to remember checklist you mentioned.
Yeah, absolutely.
It seems like a perfect way to kind of tie everything together and make sure that we've covered all our bases, right?
Yeah. It's like that final pre-flight check before you launch your newly tested code into the world.
Exactly.
And speaking of launching code, the first item on this checklist is all about making sure that even those internal components, those parts that users might not ever see directly, are rock solid.
Okay.
It says to write unit tests for comprehensive testing that includes testing of internal-only code, and then, of course, run them with cargo tests.
That makes a lot of sense.
Yeah.
Because even if that internal code isn't directly exposed, it can still impact, the overall functionality and reliability of your software, right?
Exactly.
So it's like making sure the foundation of your house is strong, even if it's, hidden beneath the ground.
Precisely. And speaking of foundations, the next checklist item reminds us to write integration tests to exercise your public API. Run them with cargo test. So remember, integration tests are all about making sure that your crate, your package of code, plays well with others in that larger Rust ecosystem.
Right, like making sure that all the different pieces of a puzzle kind of fit together seamlessly.
Exactly.
So we've thoroughly tested those individual components with unit tests, and now we're making sure that they all work together harmoniously with those integration tests. What's next?
Well, once you're confident in your code's functionality, it's time to turn your attention to the user experience, and that's where doc tests come in.
Right.
The checklist reminds us to write doc tests that exemplify how to use individual items in your public API. Run them with cargo tests.
Ah, yes, doc tests. Those live code examples embedded directly within the documentation.
Right.
It's such a clever way to make sure that your documentation is always accurate and up to date.
It is, and by focusing on individual items, the checklist encourages us to provide those clear, testable examples for each specific component or function in our public API. It's about making that learning curve as smooth as possible for other developers who are going to be using your code.
So not only are we building this really robust software, but we're making it easy for others to understand and use it as well.
Exactly.
I like that.
Me too. And speaking of understanding and using your code, the next checklist item takes a step back and looks at the bigger picture.
Okay.
It says to write example programs that show how to use your public API as a whole. Run them with cargo test examples or cargo run example name.
Okay, so this feels like the show don't tell approach to documentation, right?
Yeah.
We're not just explaining how our code works in the abstract, we're providing these concrete examples that actually demonstrate its capabilities.
Exactly. It's like giving someone the keys to a car and letting them take it for a spin. These example programs provide that more holistic view of how all the different parts of your crate can be used together to solve those real world problems.
Very cool. And it looks like we've got some flexibility in how we actually run these examples, right?
Right.
Either as test with cargo test examples or individually with cargo run example name.
Right.
I'm sensing a theme here. It's like Rust gives you the tools and then you kind of get to choose how you want to use them.
You're getting it.
Yeah.
And that flexibility extends to performance testing as well. The checklist remind us to write benchmarks if your code has significant performance requirements. Run them with cargo bench. So remember, benchmarks are all about measuring the speed, the efficiency of your code, how well it actually performs.
Right. But as we discussed earlier, it's important to be kind of critical of benchmark results, right?
Yes.
Just because a number seems impressive on paper doesn't necessarily mean that it's accurate or relevant in the real world.
Right. Exactly. Benchmarks are just one piece of the puzzle when it comes to performance optimization.
Right.
You need to understand the context, consider the trade-offs, and most importantly, trust your instincts as a developer.
And last but not least, the checklist brings back our favorite data gremlins with a reminder to write fuzz tests if your code is exposed to untrusted inputs.
Right.
Run them continuously with cargo fuzz. So it seems like fuzz testing is kind of this ongoing process, this constant battle against those unexpected inputs that could potentially wreak havoc on our code.
It is. And by running these fuzz tests continuously, you're really taking that proactive approach to security. You're making sure that your code is as resilient as possible to any malicious or unexpected data that might come its way.
Well, there you have it. A comprehensive tour of Rust's testing ecosystem, from the meticulous detail of unit tests to that holistic perspective of integration tests, from the clarity of doc tests to the chaos-embracing power of fuzz testing. Rust provides such a robust toolkit for building software that is not only correct, but also reliable, secure, and easy to use. I mean, it's really quite impressive.
Well said. And it's not just about the tools themselves, it's about the mindset they encourage. A mindset of careful consideration, of proactive problem solving, and just this unwavering dedication to quality.
It's about building software that you, as the developer, can be proud of and that your users can trust. And on that note, we're going to wrap up this deep dive into the world of Rust testing. We've explored a lot today, but remember, your journey doesn't end here. There's always more to learn, more to explore, and more ways to push the boundaries of what's possible with code. Until next time, happy coding.